started, again, everybody has 20 minutes, so I don't want to take away anybody's time. So I'm just going to go real quick introduction. I did start recording. Welcome everybody to these first set of Innovative Instruction Technology Grant presentations. Typically, folks who are, who get an IITG grant are asked to present at the CIT conference, the Conference on Instruction and Technology, which was supposed to be this past May in Oswego. And since that was canceled and we didn't do a virtual one, we came up with the idea of having everybody present in a series of webinars. And that's obviously what brings you here today. I'm going to put in the chat just now the link to the website where the registration lives. We will continue to update that website with new webinars. So we do have another set which many of you may have already registered for, that are taking place next Thursday, the 19th from 2 to 3. So what we'll also do is we're recording this now, and I'll make sure to put a tab on this website with the recordings. We'll also publish those recordings on the IITG website. The other thing I'll just say really quickly, some of you may be wondering about the status of the current year's IITG program, or for actually 2021. Usually that's already been announced early May and announced at CIT. So with the budget crisis right now, that has been delayed. If you applied for an IITG grant, I did communicate with you probably late April and said that it would be late May at the earliest. Obviously it's past late May. And I hate to say this because you probably been hearing this a lot lately, but hopefully any day now, I will get approval from the Provost Office to communicate with those who've applied for a 2021 IITG grant. But so as soon as I get that approval, I will communicate with you about that. All right, that's enough for me. Again, I introduce myself again. I guess Chris Price, I'm the Academic Program Manager for the SUNY Center for Professional Development. And now I'm going to kick it over to Dave Murray, and he's going to talk about his project, and then we'll, he gets 20 minutes, and then we'll go from there. Dave, take it away.
Thank you, Chris. Can everyone hear me and see this okay?
Yep, looks good. Sounds
Wonderful.
good.
Well, hi, everyone. Nice to virtually meet you all and see some of you. I know some of the familiar faces in there, too. The project I'm going to be presenting on for the next 10 minutes or so, and also doing a demo of, is called the Open Cyber Arena Virtual Lab. I'm a faculty member in the School of Management at the University of Buffalo, and I work with a lot of students in the areas of cybersecurity. And so that was partly what was driving some of this, this project. So just give you a brief look at what I'm going to be covering today, a very short presentation just to introduce the team, the students who largely worked on this project and did the majority of the work. Want to give a shout out to them. And then share with you a little bit of the background of this project, which goes back to the 2018 IITG grant, which was the Open Cyber Arena platform that was built, and how that's evolved into really the Open Cyber Arena Virtual Lab, which is the project for this year. So telling you the story a little bit of where we've come and where we are now. And then share with you the 10 hands-on labs that have been developed just at a very high level. And I want to spend probably half my time on just a demo. And if all goes well, actually give you all an opportunity to log into the virtual, this Open Cyber Arena Virtual Lab just to see it firsthand. It'll also be an interesting test for us to see how it works with a larger group of people too. So first of all, much credit goes to the team of students who worked on this project and who developed and designed and implemented this. And they are all on the call, I believe. So a big shout out to Chanel, Stephen, and Andrew for all their work over this past year. Stephen was actually also on the project from the prior year too. So we've had 2 years of grants. And so really the work that you're seeing is not my work, it's their work. And just want to, acknowledge that up front. I also believe on the call is Kevin Cleary, who's one of the collaborators on this project too. So thank you, Kevin, for joining us. So what's the Open Cyber Arena platform? This goes back again to 2018. We were awarded an IITG Tier 2 grant, and it was designed basically to help address some of the problems we were facing with teaching cybersecurity and technology. When we're teaching these topics, some of them by their very nature are risky, and so it's important to have a safe and secure learning environment for students to be able to learn these things without any fear of doing something that's potentially even illegal on a public network. So providing a space for students to do this learning and testing is really important. So this is what the platform provided. But it also addressed the second problem of it takes a lot of effort to build out these types of environments, these technical environments, these computer networks, these systems. And so the goal of this project was to reduce the time and effort to actually create these learning environments. And we used virtual machine technology, which is basically just a machine running inside of a machine. And you can almost view them as being disposable and reusable. So that's what makes them very useful for this type of learning. You can just rebuild them and reset them for the students. But with that, it still is a bit of a manual process. So we decided to build something that was accessible via a web browser. You didn't need any special software to install. Part of our thought was also tying this into outreach we do with high school students and competitions that we run surrounding this. So for them to be able to access this from their high schools, it's very difficult for them to install any software there just for security reasons. And this platform runs on a largely donated equipment that we received from Yahoo and Verizon Media. It's actually quite a robust infrastructure. You can see, if any of you have the technical background, 825 gigahertz of CPU processing power and 2.5 terabytes of RAM. So we run hundreds and hundreds of virtual machines on this. It's like having hundreds and hundreds of computers. And we've used this platform not only for the Open Cyber Arena, but other things we do, like our competitions we run in our camp. Anyway, that's kind of what this is built upon. We were meeting with some high school teachers, and that's what really prompted this latest project, because we said, hey, we've got this great thing for you now. Your students can use it. They can go in there. They can actually start doing things in a safe place. And they said, well, what are we supposed to teach them? And we built this great platform, but we needed to kind of fill this platform with some content. And so the focus of this year was really it was a scale up of the prior project to develop some curriculum and resources and also make it more teacher focused. So it wasn't on us to have to develop these things, or I should say to deploy these systems, but really could be self-service. So part of the project was the development of 10 hands-on labs and also corresponding videos, which you'll see in a little bit. We have the resources all there. You can take a look. And these are hands-on, right? These are ways for students to actually get their hands dirty with the technology and learn this. The other major part of this was it is self-service. And so we don't have to now be in charge of building all these things, deploying all the systems. As easy as it is, we don't want to be in that business. So now the teachers and the students can all self-manage that after we set up an account for a teacher. They can just run with it, use the platform, and do this. And it's truly point and click, where they can, based on the labs we've developed, they can just point and click, deploy their systems, and work with them. So we've really tried to eliminate that whole setup time. Instructors also have access to account management, like usernames and passwords, and creating accounts for students. So that way, again, that's not on our hands. Those are things the instructors can manage. We also have some logs that they can monitor in case they want to, in case something troubling happens in the environment, they can kind of track down what student did what and when. And also the instructor has access to all the student workspaces. We call these pods, that's kind of our lingo, but really think of it as a virtual workspace where the students use these computers and systems. It's kind of like a mini computer network. So the instructor can actually bounce around and just click on each of these things and actually view it. And I'll show you that in a minute. Another really, I think, important feature of what we've done this year is we've now created shared workspaces to encourage collaboration and peer learning. And what this allows students to do is to create a workspace and share it with other students that they can all collaboratively work within the same environment or the same desktop. They can effectively share their screen, if you will, and allow others to interact with it. And so, beyond just the content we created is really this idea of self-service and kind of peer learning and shared workspaces that makes this, I think, very powerful. These are the 10 hands-on labs. Depending on how technical they are, they may not mean anything to you, but these are focused on kind of the introductory technical and kind of cybersecurity material. And again, these are some of these topics are things you wouldn't want to necessarily do on a public network with, when you're teaching these topics. So we have this all safe and secure. And the other feature is you can see those 6 labs that I've just highlighted with the arrows. Those can be downloaded and run locally on a machine if a student wants to, in a local virtual machine. So they don't have to access our Open Cyber Arena. They can actually download, it's a pretty giant file, it's about 7 gigabytes, but they can literally run a virtual machine on their own computer. And so they're not necessarily reliant on our infrastructure to be able to access if they don't want. And so we've done that where it technically makes sense for us to do it. And some of these labs, the environment is so complex, it's very hard to replicate that locally. So let me get into the interesting part, the demo, right? So you can actually see what I'm talking about. The website's arena.ubnetdef.org. And let me take you there. And I'm first going to just show you a student view of this. So let me log in. We also have, you can sign in with OAuth or Google. We have some local accounts there. And this is the interface the student goes right to, is where they get to see their learning workspaces, or their pods, we call them. Now you can see there's this giant pod here with all these students. These are actually computers. When you say student 1, student 2, and so on, these are referring to different computers that students can interact with. And so I'm logged in as demo 30, so let me go down to student 30. And what you're seeing on the screen here is literally a Linux machine that can be accessed through the web browser. And I can click on it and log in, and I'm interacting with this just like you would with a regular computer system. So we have, through the web browser, again, give them access to individual computer systems that they can work with, they can access, and they can bounce around and, you know, check the other systems out as well. Beyond that, and we'll wait for that to refresh, beyond that, students can also create their own learning pods. And so we can call this IITG, and we can deploy it. This is the technology that's used to kind of structure that, and we'll create that pod. And this takes a minute or so, and you can see over on the left, the pod's been created. This is now grayed out because it's currently in the process of being deployed. And this usually takes about 2 minutes or so, so we're not gonna sit here and wait for that, but we will come back to that in a minute just so you can see kind of how that works. Once you create a pod, you can also create, and I'm gonna go to the shared pod here to do this, you can also create or deploy a machine. So I can call this IIG test machine, and I can pick the operating system or the lab machine that's related to this, and select it, and then deploy it. And so you can see right here, now this is another machine that's literally just being deployed. And again, this will take ideally about 2 to 3 minutes for that to deploy. But hopefully you get an idea. This is, let me go back to my student machine here. There we go. There's my desktop. It's got a web browser and everything, programs. They work with the lab inside this virtual environment that we have. And so that in a nutshell is probably the best way for me to kind of explain what this Open Cyber Arena platform is and what it does. The lab resources, which are down here, this provides a link to all the labs, the technical overview, and then the videos and additional lab documents. So this actually is the full fleshed out lab content that was also created as part of this. There we go. So, you know, this is a 12-page kind of hands-on walkthrough of this particular topic. So again, there's kind of 2 parts to this project. One is the actual content, the lab content that was created that we kind of filled in the platform. And the other focus was the collaboration kind of aspects and the self-service aspects of the Open Cyber Arena. So you can see down here in my IITG pod that I created, let me just close this one. There's now, this system's been deployed. I know that doesn't look like much right now, but just realize this is kind of their initial workspace, and the student can go and deploy their machines that they want there. Real briefly, I'm just going to show you what it looks like from an instructor perspective. So let me log out and log back in. So the instructor has access to obviously account management. They can change the roles of users. They can add users, delete. I don't think we can delete users yet, but we will be adding that. There's also the log access too. So you can see, you know, there was the account I was just using. I created a pod, deployed a machine, accessed the console. So we have some tracking. We're going to be working on making that a little more robust. And then when we go into the pods themselves, the workspaces, the instructor gets to see everything for the entire class, right? So not only do they see the shared pod that the instructor created for everybody, but they see all the other student pods that have been created for the various students, okay? So this is their kind of overview. Pods can also be shared, as I said, individually. So if I was a student, I could say, hey, I want to share it with this other user, and they can work collaboratively. And so that's, from our experience in kind of teaching these topics, we find that to be extremely valuable for the student learning. So with that, let me, and actually let me just see if we have this one ready. The IT test machine, all right, that's still deploying. It should be ready in just a minute or so. But you get an idea. You have to wait a little bit, but compared to hours or days to try to get this stuff before, we've come a long way. So if you'd like, and Chris, tell me if I'm okay on time still for a few minutes here, or just stop.
Yeah, you have about 8 minutes because
okay.
We started 2 minutes after the hour, so.
Okay, so this is the list Chris gave me of the registrants. If your name's not on the list, I apologize. But if you'd like, you can go ahead and just log in and try this out for a minute. Again, arena.ubnetf.org. you can use the username and password. Now, this is not secure, we know this, but just for demo purposes, keeping it easy. You can log in. You can then just click on the corresponding number machine to open it, and this is the password to log in the machine. So you're welcome to kind of play around with that if you'd like at this time, and kind of see what it is firsthand and how this experience works. So with that, I'll let you play, and I'll open up to questions and discussions at this time.
Yeah, so if folks want to either put in the chat a question and I could read it to Dave, or if you just want to open your mic and ask a question, or if you just want to play and then ask a question, as if anybody would like and you don't see your name there, feel free to use my username and password.
Number
First come,
22.
first served.
Yeah. And then I know that number 2 can be used also. Kevin's on the call, but I don't think he's logging in. And I don't think
I am
Al's
logged in actually. But
oh, okay. So I think you can use number 8 and number 9. I don't think Julie and Al are on the call, if anybody's name isn't on there and wants to try it out. So we'll be disabling this after the presentation. Obviously, we're not going to keep this wide open, but it's, with these types of accounts available, but we just wanted to give people a chance to kind of play around with it if they wanted to.
So Jamie said it's asking for system administrator after she logged in.
Let me just open the chat window.
Yeah.
It's this admin password, Dave, on the local VM.
Oh, this change me one exclamation. Oops, sorry, I didn't mean to stop sharing actually. So actually, let me do this because this is the beauty of it. I'm trying to get to the chat window while I'm sharing, which is always a challenge. Here we go. So that was, what number was it that you're on?
Number 2, student number 2, and that's
okay.
the screen I received. Is that
perfect? Okay, so you see, as an instructor, I can actually see what you're doing, right? And I can actually interact with this. So the password that you'll want to use is this change me number 1 exclamation, and it is case sensitive. See, and I can see you typing this in right now. So this is a great, thank you for, I didn't ask you to do this, but thank you for setting this up. But this is kind of the nature of it. So let me try to, okay, go ahead and try to log in once more. There we go. So it may have just been a case sensitivity type of thing.
Yes, that was.
Right. So yeah, that was actually a perfect example of how an instructor can pop onto a student's virtual machine and kind of provide support, see what's going on, see what they're seeing. And it will take a minute or so to load, but that's kind of the nature of this. We'd also discuss some other ideas of, which may be more of a longer term thing as we still kind of work on this in the future, having the ability to, and this is borrowed totally from Zoom and WebEx breakout rooms, but the ability for a student to raise their hand virtually, so it signifies to the instructor which VM to pop into very easily. We thought that could be a potentially useful thing.
This is really cool. Any other questions for Dave? For his team? So yeah, Kevin said you may need to refresh your browser windows after successful authentication to the VM.
Yeah, there seems to be a little delay sometimes for the screen, Kevin. I think that's what the refresh might kind of reinforce that.
Yeah, and Dave, this is probably the best load testing experience we've been able to have so far.
Right, that's why I wanted to do this. Yeah, exactly. It's good for us to get an idea of what we can handle. For our competitions, we have, upwards of 80, or I should say maybe 60 to 70 competitors on our infrastructure at a time, but this is a bit of a different platform we're using. So it's helpful for us to see this.
Hi, Dave. This is Robin.
Hi, Robin.
This is great. I'm very happy to see this. This is actually, many of you are familiar with MTech. This is kind of the same system that MTech runs off of. And so it's kind of separate from the UB administration process. But anyhow, I was wondering, can you talk a little bit about how this relates to your summer camps? It does it?
Well, it very well may. So we run a annual summer camp through the Gen Cyber program, which is a cybersecurity camp for middle school and high school students. And up until this year, we've had them in person. We are exploring the idea of a virtual camp this summer. We just got permission last week to actually pursue that idea. And we do believe that this platform would probably be used by the students to access our infrastructure, for us to conduct the lessons. And that's what kind of prompted the hand raising thing. I was thinking in the context of campers have questions and we can pop into their VMs, their virtual machines, excuse me, and see what's going on and you can give them help. The other thing that I talked to Stephen about, who's done much of the development on this, is the idea of almost in Zoom how we can have a gallery view of many people. We would like to have maybe a gallery view of multiple machines so that one of our camp mentors can be monitoring multiple students' machines at once. And you see a hand pop up and they can pop right over there instead of having that giant list on the side. So those are some of the things we are, the wheels are still turning, definitely.
And one other question in the chat, Joe asked, did you look into VMware Horizon Enterprise as a solution?
So this is running on VMware. When we first started doing this, well, and actually I think Kevin and Stephen can speak better to this about the history of this, because this goes back over 2 years ago, and the technology that we had access to and what VMware was offering at that time was not, the web-based client was not that robust, and I don't think we had the licensing for that, but Kevin or Stephen can probably chime in.
Yeah, so that when we were originally kind of conceiving of this, certainly Horizon View was there. We have experience at the university running that for our distributed VDI environment. A few reasons why, and there's a few other products out there too that are in this space but don't quite check all the boxes that Dave talked about. So NetLab is another product that's been out there for a while. But to Dave's point, look, everything costs money. And one thing Dave said that I want to be sure I'm underscoring is this is all student maintained infrastructure. From the hardware maintenance to the switch maintenance to everything on up, students are the ones that are actually running this. And Horizon View has, it's not for the faint of heart in terms of bringing that up and configuring it, and there's a lot of overhead with that. So, I mean, certainly it's a good product, but there's a few things that Dave and I wanted to see us get out of this that Horizon View just would not have done. We are a member of VMware's Academic Alliance program, and that's how we're able to license VMware across such a large number of donated equipment. But their Horizon View product is not part of their academic licensing.
So we are going to have to shift. Thank you guys, that was excellent. And please, if you have any other questions for Dave or his team, please put them in the chat. I'm sure they'll stick around. And thank you very much. Okay, we're going to shift to Mike and Cortland. So Mike, you want to share your screen and take it away?
Let me see how once again, trying to find that PowerPoint on here. Now it's missing. How do I see this? Somehow my PowerPoint disappeared from my list of selectable things. How can that be?
You can just share your desktop and then share it from there. I mean, it's ideal to share the application, but it should.
Well, perhaps I can. I did it a few minutes ago.
Yeah.
Let me see. Oh, let me see. There's a scroll bar here. I found it. Okay, very good.
Great.
All right. So let's see here.
Just
So
don't
can you
forget
see
to
that?
click. Yep, looks good.
Okay. How's that? Are we good?
Looks good. Take it away, Mike.
Okay, great. Well, anyway, thanks a lot, Chris, for inviting me to speak at this interesting virtual event. For everybody, I'm Michael Fox, and I'm a professor at SUNY Oneonta, where I have been teaching upper-level physics and electronics for 15 years now. And now our IITG grant has provided us with new infrastructure, making our engineering program unique and especially innovative, I think. My co-PI is Gavin Vitale, and he's an electrical engineer working for our music department. And he and I have teamed up to create a cross-disciplinary learning experience that involves physics, engineering, and music together. And our grant is entitled From Concept to Final Product, the design and fabrication of innovative musical devices to enhance student learning. So we obtained a Tier 1 grant for $10,000 with the following goals in mind. First, to modernize and enhance our electronic teaching lab, bringing new capabilities for learning. And second, we've learned, and I've learned over time, that music students resonate well with physics and engineering students, and we wanted to enable cross-disciplinary collaborations. And third, rather than simply teaching concepts, we want students to be able to legitimately create useful and beautiful things. And finally, we want students to think big. So this grant is a first step toward a goal of establishing an entrepreneurial program at our college, which could involve the business school as well, in which students would learn to invent, patent inventions, and form small businesses to market and sell their creations. For context, let me take you to our lab and explain the situation prior to this grant. So our teaching lab has 8 stations on 4 tables, enabling 16 students to work together in pairs. We have a smart room capability, a full whiteboard, a lot of light, and a lot of space. Now, traditional electronics courses, as taught at many schools, involve mainly blackboard or whiteboard instruction, in which the professor describes concepts and circuits in the abstract, and students are tested on these. Often, a laboratory or studio is included, perhaps once a week, in which students build simple circuits and learn to evaluate these. Our model is a little bit different. We meet 3 times each week, each time for 2 full hours of integrated laboratory and theory instruction. So we meet with students 6 hours each week. And we do this for 2 full semesters rather than 1. And the experience is fully hands-on and immersive, with an emphasis on creativity. So the students are never more than a second away from being able to assemble something to build and test. Each student work zone includes some basic equipment, an oscilloscope for observing signals, a breadboard for assembling circuits, a digital trainer for supplying bias voltages and other functionality, a collection of jumper wires for making connections, a multimeter for measuring voltages and component values, and a function generator for creating test signals. Now students also all obtain and they learn about resistors, capacitors, inductors, diodes, transistors, operational amplifiers, integrated timer circuits, logic gates, microprocessors, through which they also learn about writing code and programming, and many other integrated circuits, flip-flops, and you name it. Now students use all these components and the knowledge they acquire to design and build circuits on their breadboards. And ultimately, they include these into a creative and original final project. So the final projects have included robots, which move around and sense their environments and make small choices. These are a couple of old projects that I just found laying around our lab this morning when I had our camera. The robot on the left, for example, has a distance sensor, and he moves around, and when he senses a wall, he turns, and he plays Star Wars music, and he turns his head. Our students made these things. Other popular projects included musical applications, handheld games, specialty locks, and wireless communication devices. Popular projects involve guitar effects pedals. That's one I found laying around. 3-dimensional games, musical light displays, theremins, which is a musical instrument, equalizers, laser harps, voice-activated locks, some proximity musical organs, synthesizers, and many more. Now, a typical student circuit in the past might look like one of these. They're functional, but they're messy, involving a spaghetti tangle of wires. Let's just say not ready for prime time. So we've changed the game in the last couple of years, and now our students use Eagle, which is a computer-aided design software to create professional schematics, and importantly now, to design printed circuits of their own, to design printed circuit boards on which their components are laid out and connected by machine, allowing for final products that can be mass produced and which are objects of beauty in their own right. With our IITG grant, we purchased a Bantam Tools printed circuit board mill, which allows us to do in-house production of student-designed printed circuits. And this is the mill. And so again, to add some context, I'll show you the mill in action, creating a student. So here the mill is etching connections for a circuit, and the particular circuit which you've seen on the left of the slide. And this is done automatically by uploading the student's board design to the mill. And this mill then also drills holes into which circuit components can. And then the completed board, you see it here, is then removed from the mill, and components are then attached by hand, and then soldered to the board, allowing for tidy and permanent connections, and a final product which is beautiful and can be mass produced. Now this student project, this is a project from this semester, and I guess I'll explain during the Q&A period how we handled this semester. This student project is what I think a clever example. And this is a circuit that produces a musical tone, such as a C or an F sharp, using a tunable oscillator that's on the circuit. And it's activated by placing a hand near an ultrasonic ranger. So using our Bantam Tools mill, we created 12 such circuits, including all Western notes in a full octave, and each of which fit inside of a cube, which was designed using another computer-aided design program called in our department's three-dimensional printer. So our students now are able to use functionality involving our circuit lab, but also mechanical engineering courses put together. Now these so-called music blocks can be fitted together in any order, and they can be played singly or in groups to create music without touching anything, by placing a hand or a finger near the top of the block corresponding to a desired note. So these blocks, they can be tuned perfectly, and we managed to do so, but I didn't have time to tune them this morning, the following video. So with apologies for being grossly out of tune, here is a short demonstration of this product in action. So this is but one example of many. I decided that since I only had 10 minutes available to present something, I would just showcase one example but of many, showing the kind of capability that's available to us to make stuff. And so thanks to IITG, SUNY Oneonta has developed what I think is a novel and effective paradigm for teaching electronics, enabling multidisciplinary teaching and fostering entrepreneurship. So that ends my formal little slides here. How do I get back?
You just stop sharing. If you just click kind
Oh,
of
it's top of the screen, stop sharing. Okay,
yep.
So now I've stopped sharing. So now I'm back to being a human here. So in essence, we managed to buy some machinery that allows students not just to learn about electronics or about music, but to really wrap their head around the idea of creating something for real, which we are going to be encouraging them to market. I always tell them that they should try to make $1 million somehow. And that's what we've done with our grant. So anybody have any questions?
Any questions for Mike? I mean, a lot of, yeah. How does the design get transferred to the Bantam unit? Is there a computer attached to it?
Well, as I said in the presentation, we're using this software called Eagle. And with Eagle, you can lay out what you want your printed circuit to look like. You can place particular parts with particular geometries that you can design on your own. And you can place them on the board of any size or shape. And you lay out all the connections. You can do one-sided boards or two-sided boards. And the Eagle software creates what's called a board file, a .brd file. And all you do is you simply attach your say, laptop with the Eagle software to the Bantam Tools mill. And the mill comes with its own software. And you just simply upload your BRD file that you create to the mill. And then you just hit mill. And obviously you have to insert tools and whatnot. You hit mill and the board just rips. It creates the printed circuit. It mills it, cuts it out, and then you can remove it from the board and you can continue, as I showed you, to make stuff.
And it was also asked what the Bantam unit costs.
The mill itself costs around $6,000. Then there's a lot of ancillary devices that cost the bulk of the remaining $4,000. I don't think we quite spent everything, but again, the mill costs around $6,000. We bought some soldering irons and a variety of components. You also have to buy the blanks. The material, it's called FR1, on which you make these the circuits. It's like copper clad, non-conducting material. So you buy a variety of those. So I think it's worth it. I don't think that many electronics programs have the capability of actually producing printed circuits of their own. So yeah.
Jamie asked, how did the music department get involved, and were the cubes their idea?
Well, the music, it's over time, we're I guess, I think of us as a small size campus. I guess we're medium sized with 6,000 students, but we're kind of small, and faculty tend to interact a lot. We walk around and we talk to each other. And over time, it became clear that a lot of music students wanted to take electronics classes because we at our campus, we have a pretty robust music industry program. And students in the music industry are using electronics. They make, they might want to have some synthesizers or oscillators or filters. And again, Gavin, I came to know Gavin, who works in the music department. And like I say, a lot of our physics students are also musicians, and just somehow it became clear that music students wanted to make stuff and physics students, wanted to be involved with music. And I got to talking with Gavin, and Gavin suggested that we teach together, music and physics students together. Music students obviously didn't have the technical background, but they had a vision, they had an idea, and so we had music students come to our electronics class and talk with our students, and it just organically evolved into this, co-disciplinary thing. And, like I say, this semester we used our mill, and we had projects were always devoted to music. I showed you the music blocks, which I think is a clever project. I had another student design a pretty elaborate light display system. I had another student design a synthesizer. I had another student design a three-dimensional Rubik's Cube with lights and everything. I think the question was, how did music get involved? The answer is organically.
You sort of answered the next question here, as Carolyn asked, how did the students come up with their own project ideas? And it sounds like they did for the most part.
Yeah, what happens is I started a long time ago doing a two-semester course. First semester, people learn the basics. And the second semester, the first day of the second semester, we have a brainstorming session. I like to think of the course itself as a development group. and we all sort of knock our heads. You know, one student will spitball an idea, another one will, and we'll just, you know, as a group, you know, I see ourselves as an engineering group. We knock around ideas and we block them off into different bite-sized pieces, and we say, all right, who wants to work on this? Who wants to work on that? And we become a little engineering group. And our goal is by the end of the second semester to actually have products in hand. Up until this semester, products in hand meant, you know, those kind of spaghetti tangles that I photographed. Those were just some old ones I found laying around. And this semester, or if it wasn't for COVID, all of the students would have been operating the mill. And starting next year, hopefully if students are back on campus, the students will be working the mill themselves. And I mean to sit down with our business department and actually try to even invent a third semester where students will learn about patent processes, law, and how to form companies. And my goal is down the road to actually have products and companies and perhaps entrepreneurs graduating from our program.
Yeah, this project is just sort of the spirit of IITG in terms of its interdisciplinarity. I mean, great job. Maureen asked how you can get more information. Now, we will be sharing the recording of this session, so you can share this part of the session with folks. But I don't know, Mike, would you be willing to share your PowerPoint with whoever asks for it, or yeah?
Oh, yeah, absolutely. I can share. I have other videos. You know, I think that this way of teaching electronics, not just music, I mean, there are other applications. I think this is a paradigm that many campuses could use to make, you know, a brighter future for all of our students. So certainly, of course, you can share anything you want.
Great. So maybe if you could just share your email in the chat, and then Maureen can email you if she wants more information.
Yeah, okay. It's also easy to find me. SUNY Oneonta Physics Department. You know, there's only 6 of us. Mike Fox, you know, I'm easy to find online.
Great. All right, thank you. All right, let's shift to our last presentation. Virtual applause for everyone in Oneonta. Karen, so you want to take it away? I was muted and you are muted. So we just missed the beginning part of your presentation. So sorry.
I'm sorry. I haven't taught in a couple of weeks. I'm out of touch here. Anyway, I'll start over. My name is Karen Wicca. I'm from Genesee Community College. I'll be presenting with Jay Bushin. He's my partner in the criminal justice program at Genesee Community College. We developed a concept of trying to develop a way where our students could have more hands-on collaborative learning within the criminal justice field. So we basically proposed the creation of a criminal justice technology center in order to provide students and the local criminal justice community with a couple things. Number one, collaborative workspaces where students could be exposed to new technologies within criminal justice and allow them to have hands-on learning within these spaces, and also make them collaborative workspaces where students can work together on projects and learn the value of team working within the criminal justice field. So we requested the Tier 2 grant, which was the $20,000, and this was spent entirely on a 911 simulator, and I'll explain what that is. But the room itself contains lots of different things. So I would really like to show you the whole room, and then the 911 simulator was just a piece of it. So the grant provided one piece of technology for the room, and then the college really got behind us and backed us and bought all of the other technology for the room. So I'll explain all the components of the room. So the first thing that we needed was the technology. So Jay and I spent hours researching what would be the most valuable technology that could be utilized in the room to provide students with the best knowledge of what they would be using once they get into the field. So these were kind of the base that we came up with of what we thought we should have. So we had the 911 simulator, an Oscar 360 camera and software, which I'll explain, a judgment simulator, a forensic center, and then we have another center, which is a police video simulator and editing software. So I'll explain what each piece of those are as I go through. So the money that we received from the grant went towards the 911 simulator. So this is a simulator that creates hands-on learning for students, and they actually are placed in 911 emergency telecommunications situations, and they have to learn how to operate the technology and the skills and the communication skills necessary to become a 911 emergency telecommunicator. So basically, this is what we received. And I will tell you, a lot of these pictures look rough because this is where it was left in March. So all of this would have been up and set perfectly, and the room would have been done perfectly, but everything's at a standstill. So unfortunately, I have lots of pictures, but you'll see there's still wiring and different things that are in boxes, which is kind of silly for me to show you a box, but at least I can tell you what it's supposed to be for the room. So this would have been the student station. It is comprised of 2 computers that they can use. One will have the GPS mapping system for them, and then the other one is the data entry and information that they would have. They also have the ear set where they would be receiving the information as the call came in. The system came with its own developed manual and curriculum, and so the instructor that will ultimately be teaching this will have that set curriculum, which is recognized throughout the country, in New York State and throughout the country. And then there's a identical station that's going to be the teacher station, where they can send the calls and have the students do the different tasks that they need to do within that. And then there's the teacher manual. In the middle, I just have a picture of all the routers. So all of this is connected to the internet. It has to be its own separate internet connection because it is the GPS mapping system, and there were some issues with them logging into our personal system for some of this. So it's all separate. It's a separate system that we purchased. With this money then, what we also are doing is we are going to develop an AAS criminal justice degree in emergency telecommunications. So as far as I can tell, we're the first school definitely in New York State, and there's very few that have them anywhere in the country, an associate's degree in emergency telecommunications. We developed this whole process in combination with the director of our 911 services at the Genesee County Sheriff's Office. And there's a huge need for dispatchers right now. And it's really turned from more of a, not considered like a total career in this field to now a very professional career. They spend hours training and learning these skills. So a lot of them may not necessarily have a academic background, but they want it. So they're in the field already, so they can come back through micro-credentialing and take a class here and there, and they can work towards an actual associate's degree, either in this or in criminal justice. And we actually have several dispatchers right now that are just in the criminal justice program, but this will allow them to use the skills that they have already. So we're gonna have the AAS degree in emergency telecommunications. We'll have a certificate, and we'll also have individual courses where they can get micro-credentials along the way. So it can be a step ladder to achieving their ultimate associate's degree. We also have created 2 courses that will go along with this. We have started with Introduction to Emergency Telecommunications. This will be the basic systems operations. And then we're in the process of developing a second, more advanced course. With these 2 courses, students will already have the hours and the training that they need to become a dispatcher. And the hope is that eventually, if you achieve this and you receive these certifications, we're working with the state that you will not have to take civil service exams. You could be a direct hire into this profession. So that's the money that we spent from the grant. But I just want to tell you, so we're very excited about our room, and we want to share some other components that the school have purchased for us. Another thing that we purchased was an Oscar 360 camera and the software. This camera takes within seconds a 360 picture of any area that you want. It could be a house, a car, outside. And then that's unique in and of itself, but the software is really what makes this program. You can see the picture of the software on the bottom. Once this picture is taken, it's converted into the Oscar software, and then the police and actually prosecutors can use this to create a virtual crime scene to be demonstrated in court for the jury. So they can actually show the jury exactly what the crime scene looked like. And on top of that, you can see the little dot, red dot on the screen. You can plant, or not plant, that's not a good word to say. You can show where the evidence was actually located in the crime scene. So if there was a weapon on the floor next to her, I could create a point of interest there, and then I could click on it, and actually the actual piece of evidence could come up in larger versions. You can add forensic reports that were received from your experts. You can add pictures, you can add video testimony, and the prosecutor could use this as a demonstration in court to show the entire crime scene to the jury. This is particularly important right now in New York State. I'm not sure how many people are familiar with the changes that went through in discovery for criminal cases, but the state recently passed a lot of changes to what the prosecutor has to turn over to the defense. And one of the things that came up was that the defendant and her attorney would have the ability to go back to the crime scene and see it in real life, which a lot of victim rights people have been very upset about. So the idea is maybe this will be a supplement to that, where it recreates the crime scene as it was discovered, and then it may help eliminate some of those issues. So we're really excited. We were told by the company we are the very first academic institution that is actually using this and having our students have hands-on ability to take the pictures and use the software and figure out how it can be utilized in this classroom. We also are purchasing a judgment simulator. And you guys were all super computer people with your with your electronics and all your stuff. This is a very silly picture. I apologize, but this is in boxes in our school. It has not been mounted on the wall yet. So I just took a picture and mounted a picture on it, but this will be on the wall. It's a judgment simulator. It allows students to be, it's a huge screen that's mounted on the wall, and it allows students to be placed in simulated real-life experiences that law enforcement would have to face and make decisions on how to handle. What's really important is that it allows them to learn how to make quick judgment in situations. And obviously with everything that's going on right now, this is a super great tool to provide extra training to students on how and when and what type of force you would use in any given situation. And even more importantly, how you can de-escalate situations. So the teacher instructor will have full control over how this operates. So depending how the student responds will affect what the teacher does to the situation. So we will be using this to teach students de-escalation, communication techniques, so that if they use those properly, they can de-escalate the situation. And I'm sure Jay can talk about more detail of that at the end if he wants to give more details. We also created a forensics center. The forensics center has multiple components to it. On the left, my left, is the 10-print fingerprint scanner. So this is a digital fingerprint scanner that can take a full set of 10 fingerprints. And then they can print quality fingerprint copies of it. So we had to have a special printer to print out those copies. And then we also obtained an iris scanner so that we can scan irises. Why this is important is because then it can be used, these fingerprints can be used with this collaborative software. And what they will do is they'll take fingerprints from a crime scene and then they can match it with suspect prints. And they can use the software to do this comparison. Our next step we're hoping is to also buy a comparison microscope. So some of these comparisons can also be done with that. We also have simulated police video. So we purchased through another program that some GoPro cameras. So we're going to simulate police videos, and we have editing software for those also. The idea is to teach students the steps of, you have a video from police all the way to how do you use that evidence in a courtroom to either convict or as a defense in a criminal case. So we want to show them the system of not only finding evidence at a crime scene, but documenting that evidence and turning it into a usable way to show jurors in the court system. So we're trying to connect the whole criminal justice system together. Some specific criminal justice technology. The room also has a lot of other collaborative aspects. One of the things that we really wanted to focus on with all of this is how to make it as collaborative as possible. We want students working together, team working on these things. So a couple of things that we purchased. These are the silly pictures, I apologize, but on the bottom, those are 3 huge wall-mounted monitors that are going to go on the wall. One of the things I'll show you is these collaborative workstations that we have. With those monitors located everywhere on the wall, we can take any computer in the room and display them throughout the whole room. So if a student is working on a project and they want to share it with the class, they can be demonstrated on the wall. We have an interactive projector. The whole room has been created for video and audio recordings. So it's fully Zoom capable, and we will be Zooming and creating hybrid courses. We have the complete Crestron system that allows us to control what's on every monitor throughout the room. So it'll be fully interactive that way. And it's an interactive instructor monitor. We have large portable whiteboards. They look very small in the picture, but they're actually really large. But they're small enough where you can take them off the wall and each group can have their own whiteboards to work out collaborative assignments together and could be rehung on the wall for sharing. We also received 24 laptops, and that's the box that's containing the laptop charger. So they will be stored so all students will have access to laptops to use while they're in the room. These are my favorite. These are the collaborative workstations. Each of these tables are whiteboard tables, so they can be written on and used for collaborative work. And each one of these computers is one of the stations that I already talked about. So the first one is the Oscar, the middle one is the video editing, and the last station against the wall in the back is our forensics station. And then all of the furniture is fully movable. The tables all fold and can be stacked against the wall. The chairs can all be stacked and moved. And it was created to allow a collaborative workspace that can be movable to use for different things. We're integrating these into a lot of our curriculum. We can use them for classroom demonstrations. We're using them for collaborative group projects, and we're also using them for direct hands-on learning, just to name a few. And those are just some of the courses that those will be integrated into. Obviously, some of the hurdles that we faced with development was selling our idea. Our first idea of creating this collaborative workspace was rejected. They did not really understand our vision, but luckily we have a wonderful vice president that came back to us and said, will you explain this to us more? And the more we explained, they started to see our vision. So my first advice was make sure that when you're selling your idea, make sure that you come up with a way that really catches their attention. The second hurdle was to find enough space for this to occur in, and then obviously funding. So we've been applying for many different grants, including the grant we received from SUNY. And then we had to research the technology. advertising. Our hope is once the room is completed, we're going to use this in advertising. And then obviously COVID-19 has set us back in getting the room up and going, but we're still hoping it will be ready for the fall if we can return. But it's created a lot of benefits: collaborative working environments, hands-on learning, which I already talked about. But we are doing all of this in collaboration with our local law enforcement agencies. We've been attending meetings monthly and updating them on all of the steps that we're doing to create this workspace. We are going to share this workspace with our local communities. None of them have judgment simulators. They're very, very expensive. So we're going to be collaboratively working with our local law enforcement agencies to use our technology. Our vision is that by having them in our school, interacting with students, students will have that mentoring sort of program to see people that are working in the field and using the technology. And we also want to provide a model for other academic institutions. I've spoke to many criminal justice programs, and many are interested, even more are interested in the 911 curriculum. We're working with the New York State Department of Homeland Security to create this curriculum so that it can be duplicated throughout institutions throughout the state, since there's such a high need right now for 911 emergency telecommunicators. And then finally, obviously, self-serving. Our hope is that it will increase recruitment when we get the marketing. It will increase retention rates by having students have hands-on collaborative learning. And it will also encourage people to return to GCC for academic certifications through the micro-credentialing program. So I think I went long, sorry. So that was our presentation, and this is my information, this is Jay's information, and if he wants to add anything to the project, he should speak up. I don't know if you want to say anything else, Jay.
No, I think that you did really good with it. We're just excited about having this room, obviously with enrollment rates and stuff like that. We're really trying to market this out to the community, to high schoolers and stuff like that. This is more of a program to actually, it's great learning theory, but having some hands-on experience is just going to make things better in the long run, obviously with today's climate and everything. So that's it.
Impressive integration of the amount of technology in the space, and I thought your pictures were helpful. You know, I think we're not getting to see spaces anytime soon, so having those pictures, even if they weren't exactly what it's going to look like when it's all out of the boxes, I think was very helpful. Thank you, Karen.
You're welcome.
Any questions for the Genesee folks? Don't see any in the chat other than, an amazing resource for students. Maureen mentioned. Other folks were jealous, wanting that for their forensics course. Nicole. Okay, so if there aren't any questions, I'm going to just put in the chat one last time the link to the website where you're doing registration, where we'll put the recording for this. And I want to thank everybody who presented today for going first. And wish you luck. I mean, you still have a few weeks left of this year of IITG, and so good luck on that. Good luck on your future efforts. And I really thought today showed why this is such a great program. Just the interdisciplinary, the focus on students, and the collaboration that you took to pull this off. So thank you all. I'm just going to give you a clap, and maybe everybody else can as well with me. And everybody, like I said, go to that website for the recording, and we'll be back next Thursday at 2 o'clock.